All right, in our next section, we're going to be looking at taking the properties that we just talked about in section 1, 2, and applying those to 11 basic functions that we're going to be looking at over the next couple months. Now, some of these functions may be familiar to you. About half of them you should recognize, and some of them are going to be brand new to you that we will be working with over the next couple months, like I said, so then you will become very familiar with those. So taking our properties that we talked about yesterday, that's when we started going over the domain range, if it's increasing, bounded, asymptotes, all that good stuff. So we're going to start out with a linear function. And what we're looking at in this whole section here is we're looking at parent functions. And what a parent function is it is taking a function and making it as simple as it possibly can. So it is not doing any stretches, any shifts, any rotations, anything like that. Everything is just as plain Jane as it possibly can be. So for a linear function, the most plain way that we can write that function is y equals x. So we have a slope of 1, we have a y-intercept of 0, and that's as basic as we can go. Now we can add different slopes and we can add different y-intercepts and move this graph around, but then here we've got to realize that of those, some of these properties here will change. So understand that all the properties that I go through right now are based off of the parent function, and which is going to be the equation of y equals x. So linear equation, we have a graph of a straight line. Our domain and range, we've talked about this in the past and how a straight line, has a domain of all real numbers, because you can plug in any value for x and you'll get any value for y. We're not restricted to anything. I have all positive values for x and all negative values for x, as well as all positive values for y and all negative values for y for our domain and range. As far as this graph being continuous, it is. Decreasing, now in this particular graph, we do not have a graph that is decreasing at all. It's only increasing, and it's increasing the entire graph. So it's increasing for when x is greater than or equal to 0, and also for when x is less than or equal to 0. It's always increasing on any interval. This function here is an odd function because there is rotation symmetry to it. It is not bounded. There is no minimum or maximum to it, so it's not bounded. Here, because it's not bounded, we have no minimums or maximums. There are no asymptotes. And as far as the end behavior goes, we're looking at what's happening as x goes towards positive infinity, which in that case my y is going to go towards positive infinity. And then also what's happening as x goes towards negative infinity, which going the opposite way, we are having our y values that are decreased or going down, so y is going towards negative infinity. And so here we're just taking all those properties and we are applying it to the linear function. Now I'm going to take these same properties and we're going to look over another familiar function, which is the quadratic function. And again, we're working with the parent function. So this is y equals x squared. So we'll notice that the vertex is at the origin of 0, 0, and I do not have any stretches, reflections, anything like that taking place. For our function here, we should be able to recognize that our domain is all real numbers. I have all positive values for x as well as all negative values for x. Our range is going to be the values of y that are greater than or equal to 0, because all we're looking at here is we're only looking at positive values for y. I have nothing that's below my x-axis. Is our graph continuous? Yes, it is. Decreasing, we do have a graph part of our graph that's decreasing, and that is for when the values of x are less than or equal to 0. And our graph is increasing over here to the right for when x is greater than or equal to 0. Going on to if it's an even or an odd function, since there is y-axis symmetry, it is an even function. And our graph here is bounded below because we do have a minimum. And as far as asymptotes go, we have none. And as the end behavior, as we start looking at that, we're going to look at what happens as x gets very large and x gets real small. As x goes towards positive infinity, my value of y is increasing as well, so y is going towards positive infinity. As x goes towards negative infinity, my value of y is going towards positive infinity. And so here are the properties of our quadratic function. Next, a function that might be a little bit new to you. You've seen it before, but you haven't spent a whole lot of time with it, and that's the cubing function, so x to the third power. I'm going to run through our properties here with it. Our domain is going to be all real numbers. We're looking at all positive values of x as well as all negative values for x. Our range is also going to be all real numbers. We have positive values of y and negative values of y that are being graphed out. It is a continuous graph. Decreasing, this graph is actually increasing the entire function. So in this particular graph, it's not decreasing at all. It is increasing for when x is greater than or equal to 0 and for when x is less than or equal to 0. This is an odd function because it has rotation symmetry. It is not bounded, so there's no minimum or maximum. There are no asymptotes. And our end behavior, as x goes towards positive infinity, our values of y are going to go towards positive infinity. And as x goes towards negative infinity, our values of y are going to go towards negative infinity. And so there's our properties for our cubing function. I'm going to go through all the properties just one more time with one more function, and that's the square root function. And with this function, things are going to look slightly different than the others. As far as our domain goes, notice that our square root function starts at the origin and only goes here. It only exists in quadrant 1. So our domain is the values of x that are greater than or equal to 0. Our range, again, is only in quadrant 1, so we're looking at the values of y that are greater than or equal to 0. It is a continuous graph. There are no breaks in it. This particular graph is not decreasing at any point. It's only increasing for when x is greater than or equal to 0. This function is neither even nor odd because there is no y-axis symmetry and it cannot have any rotation symmetry. It is bounded below, and so we have a minimum, and there are no asymptotes. And as far as our end behavior goes, as x goes towards positive infinity, our value of y is going to go towards positive infinity. Now with this particular graph here, we do not have an end behavior as x goes towards negative infinity because it's starting at 0, 0. And so we will not say anything as far as what happens as x goes towards negative infinity. So of these past 4 functions, we've talked about all the properties that we did in the previous section. And now over the last couple functions, I'm only going to focus on the properties that really do matter to the function itself. For example, exponential function. You know, we can see it's continuous. We can look for if it's bounded, minimums or maximums. But really the most important parts are domain and range. That's probably the most important. Asymptotes come in there, and then also the end behavior. You know, if we can understand these 4 things on this graph, then you really do have a good idea of what's happening. So exponential function of y equals a times b to the power of x. Our domain here is all real numbers. We're going positive values of x as well as negative values of x. Our range is going to be y values that are greater than 0. Now be careful that you do not put y is greater than or equal to 0, because we do have an asymptote here, which is on our x-axis, which is the line of y equals 0. Y equals 0 is an asymptote. This particular graph here, there is no way for us to end up with y equals 0. It's just not possible, making our range greater than 0. So our end behavior as x goes towards positive infinity, y is going to also go towards positive infinity. And as x goes towards negative infinity, A lot of people here are going to want to put, okay, y is going towards negative infinity. But because it has an asymptote, what's happening here is that your y value here is actually going towards 0. So it's going towards that value of your, it's going along your x-axis, which is going to be a y value of 0. If we look at the inverse of an exponential function, which is the logarithm, and we get into that later, we'll see this graph. So again, this, you'll remember logarithms, but you might not remember the graph as well. Here with this function, we have a domain, which is not all real numbers, it's only positive values for x. And this is going to be the values of x that are greater than 0. Our range, however, is all real numbers, so positives and negatives. And in our exponential function, we had an asymptote along the x-axis. Well, now we have one along the y-axis, which is the equation of x equals 0. And behavior, as x goes towards positive infinity, our y value is going to go towards positive infinity as well. And then the next part here, what's going to happen is we've got a value here as x is going to go towards 0. Okay, as x goes towards 0, because we cannot go to the left-hand side here of negative infinity. So as x goes to 0, y is going to go towards negative infinity because it's going down here to the bottom. So we're going, as we get to the smallest numbers we possibly can, our y value is going to go towards negative infinity. Next is going to be two graphs that you've not seen before. You've worked with sine and cosine in geometry, but you've not seen the graphs to them, so this will be a new thing. Here, when you look at the sine function, it's got this nice little curve to it. We are going to be talking about how this sine function has a domain of all real numbers, and its range is a little special. Its range goes, on the parent function, goes from 1 to -1. So we have values of y that are greater than or equal to -1 and less than or equal to 1. There are no asymptotes. And the end behavior we're going to not write in at this point because it's going to go on forever and ever and ever, and it's going to oscillate here. And so it's going to be going to a different value every single time. But domain and range are really important as far as our sine function goes. Now our sine function here, it's going through 0, 0, which is slightly different than our cosine function, which actually starts at our maximum, or has maximum here on your y-axis, which is at +1. And here our domain, once again, for a cosine function is all real numbers. And our range, just like the sine function, is going to be the values of y that are greater than -1, but are less than or equal to +1. There are no asymptotes, and we're going to not write in an end behavior with this particular graph. All right, we're getting close to the end. We've got 3 more functions to go over, see where I'm at time-wise. The next one is the absolute value function. We kind of worked with this one when we were doing the graph translation theorems. Absolute value, it's making that V shape. Here we have a domain of all real numbers, and our range is going to be values of y that are greater than or equal to 0. Nothing's below your x-axis. Now we do have a even function here. It does have y-axis symmetry. It's bounded below. It has a minimum. It does not have any asymptotes. And as far as the end behavior goes, as x goes towards positive infinity, y goes towards positive infinity. And as x goes towards negative infinity, y goes towards positive infinity. And that's our absolute value function. One you might not be real familiar with. This should be, sorry, this isn't absolute value. This should be the inverse function. Or no, not inverse, reciprocal, sorry. Change this out. So it's the reciprocal function. All right, so we have our reciprocal function, which is if you take x, the reciprocal of that is 1 over x. And so taking this function here, It's a little bit different. Domain here, we are looking at a domain for all real numbers except 0. So you'll notice that we have an asymptote on our x and y axis, and 0 is not possible. So a couple of different ways that you could write this out. You could say that for your domain, x is greater than 0 and x is less than 0, or you could do all reals with the exception that x cannot equal 0. As far as our range goes, it's going to be the same thing. We're looking at the values of y that are greater than 0, the values of y that are less than 0, or looking at all real numbers for when y cannot equal 0. We do have two asymptotes. We have one along the x-axis, and we have one along the y-axis. So our equations here are y equals 0 and x equals 0 for those asymptotes. And behavior, as x goes towards positive infinity, our value right here is x goes towards positive infinity, your value of y is going towards 0. And as x goes towards negative infinity, your value of y is also going towards 0. As x gets very small, our value here of y is getting closer and closer to 0. And that's our reciprocal function. The last and final function that we're going to be going over is the logistic function, which comes up once we start working with logarithms. And this function here has kind of a little funky graph to it and a little interesting equation. And its domain is going to be all real numbers. And its range is only going to be the values of y that are greater than 0 and less than 1. We do have two asymptotes here. We have an asymptote on your x-axis, which is the equation of y equals 0. And we also have a asymptote at y equals positive 1. And behavior, as x goes towards positive infinity and as x goes towards negative infinity. As x goes towards positive infinity, what's happening here is your y value is going towards that positive 1. So y is going to go towards 1. As x gets small and as x goes towards negative infinity, your graph here is going towards that value of 0. So y is going to go towards 0. Now what we've done here is we've taken 11 different functions and I've given you the graph and I've talked about some of the properties. These are some properties that you really need to understand. Things that I want you to know for all 11 of these is what the domain and range are, what are the asymptotes if there are any, and looking at the end behavior. Those are 4 things on all 4 of these graphs that you really should be able to understand. If you have any questions about any of the functions, make sure that you write it down like always, and we can address those in class tomorrow.